Okay, percent yield is going to be the last topic that we're going to talk about in our stoichiometry unit, okay? Percent yield should kind of be intuitive because you already know how to calculate percent error, okay? And percent yield and percent error tend to be opposites of each other, okay? So if you think about what a percentage is, right? A percent is a part over a whole, right? Yield means how much do I make, okay? So a percent yield is going to be what is the percentage of how much I made out of how much I should have made, okay? So percent yield is going to be the actual yield, what you actually yield inside of the lab, divided by theoretical yield based off what you calculate through stoichiometry, okay? So it's going to be actual divided by theoretical, and then obviously since it's a percentage, it has to be multiplied by 100, okay? So let's think about this for a second. What factors could influence a percent yield to be high or too low, okay? So if it's too high, that means what? My numerator is going to be larger than my denominator, okay? So my actual would be too high. Okay? Where if it's too low, that means that my theoretical will be more than my actual, which means I'm not yielding as much as I should be. Okay, so that means that my theoretical is going to be high. Okay? And we'll look at this when we start to get percent yields that are greater than and less than 100. And we can talk about why those things might have happened. Okay. So let's look at one of these types of problems, okay? Now sometimes it's easy and I just say this is the actual, this is the theoretical, what's the percent yield? But obviously, since you can calculate theoretical yield from stoichiometry, I'm probably going to make you do that first before you solve for percent yield. Now here's the thing, unless you're performing the lab, you don't know what actual is, right? So I will always have to give you the actual yield in a problem, unless, of course, you perform the lab yourself. Okay, so let's look at an example. It says, if 75 grams of siderite ore, which is iron 2 carbonate, is heated with excess oxygen, okay, so that means that excess oxygen. So that means that this is going to be the limiting reactant. Okay, anytime I have something in excess, that means I have an abundant amount of it, so my other substance is going to be the limiting reactant. Okay, 45 grams of iron 3 oxide is produced. Determine the percent yield. Okay, so the first thing that we're going to have to do is balance the chemical reaction. Okay, so I have 1 iron, 2 there, so I'm going to put a 2 there. Let's see here, 2 carbons, 1 carbon, so I'm going to need to put a 2 here. And then oxygen's last, so 2 times 3 is 6, plus 2 is 8. 4, so this is 4 plus 7. So I need to get an even number here. So what I'm going to do is I'm actually going to make this an even number and restart here. Okay, so now I have 4, so I'm going to put a 4 here. Okay, so I have 4 carbons, so I'm going to put a 4 here. So 4 times 3 is 12, plus 2 is 14, and then 8 times 2 is 8, plus 6 is also 14. So this is going to be a balanced chemical reaction. Okay, so it says determine amount of product using the given amount of reactant. Okay, note that siderite is the limiting reactant here because we have excess O2. Normally, we would have to determine the limiting reactant next. That's typically how the reaction starts, okay? All right, so what we have to figure out, this is how much is actually being produced. Okay, so this is our actual, meaning this is what I did the lab, and I made 45 grams of iron 3 oxide, okay? So with that being said, I need to figure out from stoichiometry how much I should make, okay? So I'm given 75 grams of my siderite ore, and so I need to convert to iron 3 oxide. So I'm going to say question mark grams of iron 3 oxide is equal to my 75 grams of siderite ore, which is FeCO3. Okay? So I'm going to need to convert. So I need to put, for my grams in the bottom, and I need to put my moles in the top. And for every 1 mole, I need to figure out how much this weighs. So iron is 55.85 plus carbon is 12.01 plus 16 times 3. So I'm getting 115.86 grams. Okay, so grams cancels. Now I can use my balanced chemical reaction to move from mole to mole. Okay, so for every 4 moles of the siderite ore, I will create 2 moles of Fe2O3. Okay, so moles cancels. Now I convert from moles into grams because I need to be in grams in order to determine yield. Okay, so I need one more conversion. So for every 1 mole of Fe2O3, okay, I need to figure out how much that weighs. So again, iron is 55.85 times 2 plus 16 times 3, and I get 159.7 grams of Fe2O3. Okay, so now I can do this math. So I'm going to do 75 divided by 115.86 times 2 divided by 4 times 159.7, and I get 51, watching sig figs, 0.7 grams of Fe2O3. Okay. All right. Now, the math is telling me, theoretically, from this chemical reaction, I should make 51.7 grams of Fe2O3. But the problem is telling me I only made 45. So I actually need to do a percent yield here to see how much I actually created from what I should have created. So percent yield is going to be equal to actual divided by theoretical times 100. Okay? So in the lab, I actually created 45 grams. I theoretically should have created 51.7 grams. So my percent yield for this problem is going to be 87.0%. Okay? So the 87 means I yielded 87% of iron 3 oxide, okay? Which means I have a 13% error somewhere because I didn't create 13% of what I should have. Okay, does that make sense? Okay, so let me do another example. Hang on, let me get my other paper. Okay, let me do one more example here, okay? This is on page 230 of your notes. It says, what is the percent yield if 4.65 grams of copper is produced? Okay, so this is going to be our actual. Meaning, I went into the lab, I did this experiment, and I actually made 4.65 grams of copper. Okay. Now this is telling me when 1.87 grams of aluminum reacts with 5.89 grams of copper 2 sulfate. Okay, so I'm going to have to figure out who is the limiting reactant here, okay, because I'm given 2 reactants, okay? So, but the first thing I need to do is write a chemical equation. So I have aluminum plus copper 2 sulfate. So copper is plus 2, sulfate is SO4 minus 2. Charges cancel, so it's going to be copper sulfate. So aluminum is going to come in and kick copper out. So copper is going to be by itself now. And then aluminum's charge is plus 3. So it's going to be Al2SO4 3. Okay, and then I need to balance. So I'm going to put a 3 here, a 3 here, and then a 2 here, and I should be good. Okay, so now we have to determine the limiting reactant. Since I'm finding the percent yield for copper, I'm going to find limiting through copper. Okay, so I'm going to say question mark moles of copper is equal to my first reactant, which is 1.87 grams of aluminum.
Mrs. Leck, please.
So I'm going to say for every 1 mole of aluminum, aluminum weighs 26.98 grams of aluminum. Okay? Grams cancels. Now I can go for every 2 moles of aluminum from the chemical reaction, I will create 3 moles of copper. Okay? So if I plug this into my calculator, times 3 divided by 2, I should get 0. With 3 sig figs, 104 moles of copper. Okay, now I have to do it again with my other reactant. So now I have to say question mark, moles of copper is equal to the 5.89 grams of copper 2 sulfate. Okay, so for every 1 mole of copper 2 sulfate, it will weigh, so copper is 63.55 plus 32.07 plus 16 times 4. I get 159.62. And then for every 3 moles of copper sulfate, I will create 3 moles of copper. Okay? So with the copper 2 sulfate, I should create with 3 sig figs, 0.369 moles of copper. Okay? Who limits the reaction? Okay? This is the smaller amount of moles. So my 5.89 grams of copper 2 sulfate limits how much copper I can make. Okay? Now, if I'm only making this amount of moles of copper, I can then just say question mark grams of copper equals the 0.0369 moles of copper, right? And for every 1 mole of copper, it weighs 63.55 grams of copper. So then I can solve how many grams of copper I should be making. And I get, with 3 sig figs, 2.35 grams of copper. So theoretically, from this chemical reaction, I should create 2.35 grams of copper. But I'm creating 4.65 grams of copper. Okay, so to calculate percent yield, I'm going to say actual minus, or divided by theoretical, times 100. Okay, so I actually created 4.65 grams of copper, and I should have only created 2.35 grams of copper. So what this is indicating is I'm going to have a percentage that's larger than, and so I have an error, or a percent yield of 198%. Okay, and what that indicates is that we probably have some of, if we're only trying to find this copper, I probably have some of this attached to the copper, or I didn't react all of these all the way, which is contributing to extra mass. Okay, so that's the lecture on percent yield, and that's it for stoichiometry. Thanks, guys.